Hi, I'm Graeme Larsen. Welcome to today's edition of Bedtime Mathematics. Today, we're going to be solving a word problem involving cubic functions.
The question reads, the Sukalichi family members are very competitive card players. They keep score using a complicated system that incorporates positives and negatives. My score for the last game night could be modeled by the function s of x is equal to x minus 4, x minus 6, where x is less than 10, x belongs to the set of whole numbers, and where x represents the game number. Part A asks, after which game was my score equal to 0? Part B asks, after which game was my score negative 5? Part C asks, after which game was my score 16? And Part D asks us to draw a sketch of the graph s of x if x belongs to the set of reals, and to explain why this graph is not a good model to represent my score during this game night. Since the equation for her score has 3 x's, we can tell that it's a cubic function from the polynomial functions unit. Polynomial functions such as this one are often used by economists to do cost analysis and determine trends in the market. The job of an economist is to study the production and distribution of resources by collecting and analyzing data, researching trends, and evaluating economic issues. The important things to look at in this question are the equation for Maya's score and also the fact that the number of games belongs to the set of whole numbers. This is an important thing to keep in mind, and we'll see why later in the video.
Question A, after which games will my score be 0, has a fairly straightforward answer.
First of all, we know that my score can be modeled by the equation x minus 4, x minus 6. And since our score is 0, we can set it equal to 0.
Now, since this equation is equal to 0, it means that each one of these sections, since it's multiplication, have to be equal to 0 in order for this to make sense. For the first one to equal 0, x needs to be 0. For this one to equal 0, x needs to be 4, since 4 minus 4 gives you 0. Then for the third one, x needs to be 6. Now that we know the games after which her score will be 0, we can say that therefore, at the beginning of the game, since 0 means they haven't played a game, after game 4 and after game 6, she will have a score of 0.
Part B, after which games was my score negative 5, is slightly more complicated than Part A just because it requires expanding.
First, we need to write out the equation for my score again, but this time we're going to set it equal to negative 5. In order for us to find exactly where this is going to happen, we need to bring negative 5 over to the other side so that this is equal to 0 over here. But first, we need to expand this in order to be able to bring the negative 5 over. Expanding this will give us x cubed minus 10x squared plus 24x is equal to negative 5. Then we bring the negative 5 over to the other side, which gives us x cubed minus 10x squared plus 24x plus 5, since to get this over here we need to add 5 to both sides. Once we move the 5 over, that side's equal to 0. The next step in this question is a little bit more complicated, as we have to find a factor and use synthetic division to get a quadratic out of this. If we plug in 5 to this equation, we get 0, which means that 5 is a factor. We can then use that in synthetic division to break it down into a quadratic. Put the 5 here, bring the 1 down from the x cubed, bring the negative 10 down from this, the 24 down from 24x, and we bring the 5 down from the plus 5. We bring the 1 down, multiplied by 5 gives us 5. Add 5 to negative 10 gives us negative 5. 5 times negative 5, negative 25. Add negative 25 to 24 gives you negative 1. 5 times negative 1 is negative 5. 5 plus negative 5 is 0. We can then take these three numbers, and that gives us our quadratic. Gives us x squared minus 5x minus 1, and we put x minus 5 in front of it since 5 was a factor. Now that we have our quadratic, we need to try and factor it. However, this quadratic that it gave us is unfactorable. In the question, it says x belongs to the set of whole numbers, which means it can't be a decimal. If we were to plug this quadratic into the quadratic formula, it would give us a decimal, which wouldn't work for our answer, and therefore the only answer will come from here, which means x is equal to 5. Therefore, we can say that after the fifth game, my score will be negative 5. Question C, after which games was my score 16, is very similar to the last question, just with different values. For this reason, we're going to take a very similar approach. First, we write out the equation for her score. Since her score is 16, we set her equation equal to 16. Again, we're going to expand out. But this time, we're going to bring the 16 over, and it's going to give us negative 16.
This whole thing will be equal to 0.
Again, we're going to try and find a factor. If we plug in 2 to this equation, it gives us 0, which means 2 is a factor. We can then use synthetic division again to give us another quadratic. Again, we're going to take the 1 from here, negative 10 from here, the 24 from here, and the negative 16 from here. The 1 comes down. 2 times 1 is 2. Add that to negative 10, gives you negative 8. 2 times negative 8 is negative 16. Add that to 24, gives you positive 8. Multiply that by 2, gives you 16. Add that to negative 16, gives you 0. From this, we can take the quadratic x squared minus 8x plus 8. Since it's 2 that's the factor this time, we can put x minus 2 right in front of it. Since this equation up here was equal to 0, this is also going to equal to 0. Again, just as in question B, this quadratic is not factorable. For that reason, it's useless to plug it into the quadratic formula since x belongs to a set of whole numbers and therefore cannot be a decimal. For this reason, we just look at this part of the equation right here, and we know that x is equal to 2. Therefore, we can say that her score was 16 after 2 games. Finally, part D of this question asks us to draw a sketch of the graph for Maya's score. If you recall, the equation for Maya's score is x minus 4, x minus 6 is equal to 0. Therefore, her zeros will be at 4, 6, and 0. If you remember from part B, her score was negative 5 at around 5. From part C, we learned that her score was 16 at around 2. We can then connect these dots using a curved line, and that shows us a sketch of how her score will go throughout the game. The reason this graph is not a good model of my score is because it shows us values in between whole numbers, but according to the question, the number of games can only be a whole number. Therefore, there should only be points on the graph and no line connecting, since there will be no score in between games. Thanks for watching this edition of Bedtime Mathematics. Once again, I'm Graeme Larsen, and I hope you learned a lot from this lesson. See you next time.